Good morning, colleague. Today we are going to solve exercise 337 from the Sadiku Electrical Circuit Fundamentals book. In this exercise he tells me to solve exercise 3.8 by applying loop analysis. In exercise 3.8 they asked me to determine a tension B sub 0 through nodal analysis. In the circuit of the figure, attention. The voltage that falls across the ohms resistance is the same voltage between this point and this point. Good. This time we have to do it through loop analysis. First I mark the loops here. I say that there is the current I1 in here, well, the current of the 1 and the current of loop 2. Now in loop 1 EH, I have to be 2 for the current and 1 that gives me the voltage. At this point let's remember that loop analysis is doing a voltage analysis. If the voltage here, well, the voltages that are in a loop are 2 times the current 1 gives me the voltage in this resistor plus 3 times. The current and 1 the voltage. Here more a voltage source in volts because it would be only 3 volts plus the voltage in this resistor which would be 1 because it is in the loop, 1 because it would be and 1 minus and 2 all of that equal to 0. Now we start to apply algebra, which would be 2 and 1 plus 3 and 1 more. I'm going to pass this one to the other side of the equal, so it would be and 1 minus and 2, right? 1 times 1 times minus 1 2 is going to be equal to minus 3, and here it would be whatever I have. There 1. Well, it would be 2 plus 3. 5 plus 166 and 1 minus and 2 equal. I'm going to put it here. 6 and 1 minus and 2 is equal to minus 3. This would be the equation 1 in loop 2, which is the one that is here now as in mesh 2. Well, it would be 1 that multiplies A and 2 minus and 1 as we are mesh 2. Well, it would be Y2 minus and 1 minus the voltage here that. It would be 3 volts plus 5 times the and 2 more. This is a dependent voltage source, but it is voltage, so it would be 4 times V0. We must identify or convert CB0 in terms of current. Not all of this is going to be equal to 0, so 1 by this one we are going to multiply it. So it would be and 2 or well, it would be and 2 minus and 1 and plus 5 and 2 plus 4 versus sub 0 equals 3. Note that we need to convert V sub 0. Let's look at what V sub 0 is equivalent to. V sub 0 is equivalent to the voltage that was in the 2 ohm resistor. The V sub 0 is here. We observe that the polarity of the sub 0 resistor is more up, less down, and I am taking the current going up. So sub 0 is going to be equal to and the resistance, which would be 2 times the current that goes through that resistance. The current that goes through that resistance. We see that the I1, well, I put minus the and 1. Why did I put it less? Because let's observe that the polarity of this resistance is more up, less down. It's like the current comes like that. So since I am taking the current in the opposite direction, the current would be less. Let's remember that P sub 0 the resistance due to a current that comes here, but since the current I1 goes upwards, it has to be EH the negative of that current, that is, in the opposite direction. If here it had been more or less, plus and minus in this polarity, there if we could take it as a positive 1, then V sub 0 is equal to minus 2 times the and 1. That's what we're going to replace there. So I'm going to rearrange this. I'm going to put minus I1 plus I2 first. He hasn't done anything. I put this 1 first. Then this plus 5 and 2 plus 4 times multiplied sub 0. But sub 0 is minus 2 and 1. That's equal to 3. So this would be minus I1 plus I2 plus 5 and 2 Why not? But I'm doing this well now. Well, here it would be less. Minus 4 times 2. 8 minus 8 and 1 would equal 3. Anything that has I1 EH. Here there are minus 8 and minus 1 gives minus 9. And 1 and 2 would be 5. Plus 2 would be 7. And this is 5 and 2 plus 2 would be no. This is 6. What a pity. 5 plus 1 is 6. I confused it with this too. A very common mistake. Plus 6 and 2. Be careful with that. Equal to 3. That would be my two equations with two unknowns. The equation 2 6 minus 1 equals minus 3 minus 9 6 equals 3. Let's put 6 space minus 1 semicolon minus 9 space 6 and here I put 3 semicolons in 3. And here I have the values of the current minus 0.5556 and minus 0.3333 amperes. I'm going to put it over here. And 1 is equal to negative 0.5556 amperes and 2 minus 0. Minus 0.33. 33 amp. I have the 41 and the 42. And we need the voltage here. So the voltage V sub 0. Let's notice that it was already here. It would be negative 2 times the current and 1 would be negative 2 and the current 1 minus 0.55 and effectively it will give us the positive voltage as we had it here. How am I going to do it? I'm going to do more. The variable the and 1 is solution 1. I'm going to put minus 2 for the variable sol in position 1 or position 1. I am multiplying it by this which is the current and 1. And that gives me 1.11 volts. V sub 0 1.11 volts. You can check the video of exercise 3.8. And you will see that it is good. See you in the next exercise.